Good morning. I hope you can hear me. There's some noise on the background. Sorry about that. I'm in a co-working place today. It's the webinar, the 18th webinar. We're going to talk about object-oriented programming and the situation with the getters, which we actually discussed in the webinar number 4, and agreed that these getters are actually not a good thing in object-oriented programming, and I hope we agreed. And if you wanna get back to that subject, you can watch the webinar number 4. But today the subject is a little bit different. We're gonna talk about what's the possible replacement for getters in object-oriented programming. So what can be done better, and why this better thing is actually a better thing than getters. So just a few words first what getters are. The getters are methods which allow other objects to retrieve data attributes or get access to data attributes from our object. So our object is basically, if it has getters, it basically is sort of a container of data, which these data they could be used, or they should be used by other objects somewhere else. And I want to give a number of examples today, and I will use my my book, Elegant Objects, the volume number 2, which will describe that problem in a bigger context, and we'll give examples and explain what's going on. I will use that book as an example today to demonstrate. Instead of slides, I will just use examples from the book to show what's going on. So let me share that first with you, and we'll see if it works. One sec. Let me find that book here. So yeah, here it is. Yep. So it's going to be the entire article, the entire section will be in the book, which is called, let me scroll up, which is called Printers Instead of Getters. This is exactly the title of the webinar. And here's the example of how these getters are typically used. So first of all, for example, we retrieve some book from the database. So we call database fetch, we get the book out of the database, and the book is basically a container of data. It could be called a DTO, or a domain object, or entity object. There are many names for that, but this book is actually a container of attributes with some data coming from the database. And then we want to render this book on the website. We want to show in the HTML format what's in the book and how it looks. So we create some rendering engine which has this template, probably book HTML, and then we put this attribute, we inject this book into the engine, and then we say engine render. I'm sure you've seen that. For example, the Apache Velocity is one of the popular libraries for templating, for doing that kind of rendering. And then inside this HTML document, something like that will happen. So these placeholders, they will be by the engine, they will be replaced by the actual data. In order to get the data, the engine will call this a number of getters. So the B is actually the book. So B, get ISBN, get title, get author. They will be the getters which the engine will call on the book, retrieve the data from the book, and then use this data in order to render HTML page. This is a very traditional approach, and it's wrong. It's wrong because for many reasons, like we discussed in the webinar number 4. But the main reason, the bottom line is that the book is not really an object. It's a data container which doesn't know what's going on. It doesn't control the process. It doesn't know what's going on. It just I'm just checking the camera here. Yeah, it works. So it doesn't know what's going on. It's just being a container of data which just transfer the data from the database to the rendering engine without actually understanding of what's going on in between. So the object doesn't have control of that process, and the object doesn't understand the semantic of this, what's going on. To answer that question, object cannot do that. So object being just an anemic data structure which has no influence on the process in general. It's wrong for many reasons, but Now the question is, so what can we do in order to fix that? What is the better solution? What's the alternative? The alternative is to create a printer, to introduce a printer. There's some text in the book, and then the solution is to let the book itself, to teach the book itself, to give the ability for the book to print itself into the HTML format. So in the worst case scenario, it will look like a primitive generation of the string, of the text inside the book class. But this is a little bit more complex approach, a little bit more smart. So again, we're retrieving the book from the database, and then we're making some page, which is still like some kind of a rendering engine. But then we're telling the book, we're asking the book to print itself to the page. So the book will initiate the process of printing. The book will call the engine, and the book will tell the engine of what the data needs to be rendered, and what kind of data, and when exactly it's going to happen. So the key difference here is that not the rendering engine is pulling data from us, pulling data from the book, but instead the book is actually printing the data into the rendering engine, for example, into HTML. Inside the HTML, it will look kind of close. It will look almost the same. So we'll also have almost the same HTML, a template, but here there'll be also some kind of placeholders. But these placeholders, they are not anymore, they don't trigger the rendering engine. They don't instruct the rendering engine to pull some data from where. They're just placeholders which will be replaced by the engine when the book says print. And this is how the book print inside could look like. For example, I'm assuming here that the page is an immutable structure, so it's a rendering engine, but it's still immutable. So here I'm saying that I'm just getting the page, and then I'm injecting into the page. I'm injecting the data from the book. I'm using the internal attributes in the book to inject them into the page. I inject 1, 2, 3, and then I render it here, and I build the, oh, that's probably wrong. It shouldn't be void. It should be string here. But the thing is that all of these 3 attributes are now private, and the book doesn't have any getters. So nobody from outside of the book can actually ask the book to return back the ISBN, for example, or the title. These 3 attributes, they're encapsulated, properly encapsulated, and when somebody needs this book to be printed in some format, because now it doesn't say there's HTML, it's just some kind of a page. This page will accept that stuff. It could be JSON page, it could be HTML page, it could be console page, it could be PDF page, any kind of page. The point is that the book is actually giving the data to the page. It is printing into the page. It makes the decision of when and how to print. It's not the page pulling out the data, but the data is being delivered to the page when the method print is called. I think it looks like obvious technically how it works, and looks obvious what the differences are, but there are a few like serious concerns about that, which we will discuss right now. But for now, I think you understand what's going on. So instead of, again, let me repeat it like quickly. So instead of making our objects data transfer objects, or data containers which just transfer data from one place to another, and then these places make decisions of when actually this data is supposed to be used. So these places actually maintain the semantics, so they know what's going on. Instead, the object knows what's going on. The object was retrieved from the database, this book. It came from the database, and now it knows how to print itself to HTML. So it may sound unusual, I'm sure for many of you, may sound unusual because this is not how most object-oriented systems work right now. This is not how they are designed. For example, Hibernate doesn't exactly work that way, and many other systems don't work that way. So they expect us to actually use objects as data containers, and then build procedures around them, which will know how to use this data, and which will know how to convert that data from attributes, from these getters, into the HTML, for example, or JSON. But the right way, I think so, the right way is to use printers instead. The printer is a method which stays inside the object, which knows which attributes are in there, which doesn't show these attributes to anybody else. But when it's called, when the method print is called, then it uses the attributes. It knows which attributes to use in order to inject the data to the destination. For example, in this case, the destination is the page. In other cases, the destination could be a console or anything else, or I don't know, an output stream, or a byte array. So it could be anything. And every time we call the method print, and it prints it to the destination. And now the questions, now the problems. There are basically a number of concerns which I've heard many, many times, and let me go through them. The first concern is called, what about the single responsibility principle? So the single responsibility principle says that, it's like just a paragraph here which says that it's a great principle. It is, the principle means that an object has to do just one thing. But it doesn't say exactly like what this one thing means. So it's just basically, this principle is just a simple definition of the principle of cohesion and coupling. Very old principle, which says that our objects, they have to be quite cohesive, so that everything should stay together as much as possible. But at the same time, the functionality should be decoupled from the other piece of functionality. So I'm totally in favor of this principle. I like the idea of the single responsibility. Absolutely, this is a great idea. But it looks like our printers, they actually violate this principle. Look at this example. For example, if we have the class book and then we want to print to page, then we have one method. Then we want to print to byte array, then it's a different method. Then we want to print to JSON, there's a different method. And we may have like 10 of that methods. We may have so many of them that the book will be really huge. And the concerns that, well, what about this single responsibility? It looks like the object is responsible for, first of all, it's coming from the database, and then second, it's responsible for printing itself to 3 different formats: to JSON, to byte array, and to the page. So what about this? So how could it be single responsibility anymore? It's not single anymore. It's like 3 or maybe 4 responsibilities: print, and come from the database. And my answer to that is that yes, indeed. Yes, definitely, we are violating the single responsibility principle here. We definitely in this case, our object definitely is doing too much. And don't be surprised, but I will have to say that yes, I admit that. I agree that in this case, the responsibility, that the object becomes bigger, and it's responsible for too many things. But my point is that if we have to choose between single responsibility principle and encapsulation idea, then we have to choose the encapsulation. So breaking encapsulation in order to not be responsible for too many things is not an excuse. So if you look at the object and it perfectly encapsulates everything, it doesn't have any getters, and then you realize that you need to introduce getters in order to expose your data to somebody else, and you don't want to break the single responsibility principle, and then you decide to break the encapsulation principle, that's wrong. Because encapsulation is way more important than single responsibility. It's better to have an object which is responsible for many things instead of having a data container, which is not responsible for anything. It's just being a data container which just transfers data from one place to another. So my answer here is yes, I understand that single responsibility principle is being violated by printers to some extent. We'll discuss later how can we avoid it, actually, how we can solve even that problem. But I do admit that the problem exists. So yes, we make our objects bigger. We move functionality from the outside, because before the functionality was outside. The functionality was in the rendering engine, or the script which wired together the rendering engine and our object. So our object was a dumb, anemic data structure, data bag or data container, and then we had some functionality which stayed out, which was located outside of an object. Now we have them together. And yes, we definitely violate, in this case, we definitely make the object bigger and we violate the principle, but the encapsulation is not broken. This is the most important thing. Don't break the encapsulation. Don't turn your objects into non-objects, because in this case, the entire object-oriented programming is ruined. Let's continue, and then we'll discuss. The second problem is this: God objects. So we may end up having an object which is called monster object or God object or whatever. There are many names for that. And why that will happen? Because it's possible, because we'll introduce more and more printers in order to satisfy requests from our clients, who will come in and say, we need you to know how to print itself here, and we need you to know how to deliver data in XML now, not HTML, but a different format. And every time we will have to put more and more functionality into the object. And of course, we eventually may have the God object. So it will be not maybe a monster object. We maybe not have like 50 methods there, but we may have like 10 or something. And it's possible. It's a possibility. My answer is that, yes, the same answer. Yes, I admit that. It may happen. But this is still a smaller problem than a data container in object-oriented programming. Because we still, if the object is huge, if the object is like monster object and it has like even 50 methods, but it's a solid object. It's not a data container. It doesn't expose the data to the outside. It doesn't violate the encapsulation principle. It's a better solution than this kind of object. Even if it is huge, it's even better than the data container. And now the problem number 3 is code duplication. Code duplication also may happen if we have these printers. For example, look at this code. This code prints, this is the book with the one printer. The printer prints to JSON. This is Java. So it tries to generate the JSON document from these 3 attributes. And then it prints the JSON to, first of all, it builds the JSON object, and then from that object, it creates the actual string, like the actual text with JSON. And then we have another class, another object, where another method print to JSON is there. For example, this is book, and then we have another object which is called article, or I don't know, user. And then we want to generate JSON over there as well. And we will have to use the same 3-4 lines of code in that place as well. So the mechanism of building JSON will be duplicated. We print it here, we generate JSON here, and then we generate JSON in another object. And these JSON generators, they will look quite similar, and not just similar, they will look identical. These 4 lines of code, they will be over and over again and again and again in different places. And it's logical, because every time this print to JSON method has to be implemented, it has to somehow generate the JSON. And that's probably one of the reasons why there are these libraries like JAX-B, for example, were introduced in Java and many other languages, where they expect our objects to be, let's call them like, that's like simple data objects which have getters. And these libraries, they rely on these getters because it was easier for everybody to move the functionality of building, for example, JSON and XML to some library, to some utility outside of our objects, and then open our objects, break the encapsulation, let all of these libraries see what's inside our objects, and they will just build JSON, and they will just build XML or whatever. Any possible things they will build, because our objects are not anymore black boxes for them. They're open. They can see what's inside. They can see what's inside us, and they can implement this functionality. This 4 lines of code, they implement outside of the object. They implement in one place. There's no code duplication. Definitely, the code is not being duplicated, but our objects are open. They're not black boxes anymore. They're not closed anymore. They don't encapsulate anything anymore. And we're not anymore writing object-oriented software. We cannot. If the principle of encapsulation is broken, everything is broken, because it's procedural programming from now on. It's just code and data. It's command and control. It's not it's not, you know, delegation and trust. It's command and control. It's a completely different paradigm of programming, which is, you know, which is worse than object-oriented programming. Object-oriented programming was introduced in order to solve the problems of procedural programming, and now we just see it's obvious that that the problem is not solved. So that's the big concern, and but the code duplication, yeah, I'm getting back to the main problem. So the code duplication, yes, again, I have to admit, yes, we will have code duplication. We will have these 4 lines of code duplicated here, well, present here, and will be present in another method, in another printer, in another object. So they will look the same, and maybe sometimes they will look completely identical. But again, I have to say that this problem is smaller than the problem of broken encapsulation. So this problem, even having 2 objects which duplicate each other with 2 methods, print to JSON in one place and print to JSON in another place, which look almost identical, is definitely a problem. But it's a smaller problem comparing to the problem of broken encapsulation and objects being just data structures. So three things which I admit, definitely we will have single responsibility principle violated. We definitely will have code duplication. We definitely we may have monster objects, like 2 big objects. But there is also but coming. So it's not all the bad things, but it's solvable. These 3 problems, they can be solved. And I'm suggesting that this kind of thing, which I would call utility objects or something like that, which would help us to get rid of that problems. These 3 problems, they are solvable. As long as we agree that we are only working with printers and not getters, then we will be able to solve these 3 problems of code duplication, of single responsibility principle, and the monster objects. For example, first of all, let's get rid of the code duplication. So we don't want to duplicate this JSON generation in every place because it's, you know, it's redundant. We are doing it over and over again and writing the same code. Okay, we introduce another object. We introduce another utility object, which is called JSON page or whatever, which accepts some data and generates JSON for us. So it's going to be not exactly, but the similar functionality to the library we had before. But this library now is called from here, from the printer. Before, it was the code which stayed outside of the book, and it was just getting data from the book through getters, and then building JSON. Now we put this library into the object, into the printer, and now the printer is calling this supplementary thing in order to print something. So the book is in charge. The book is not, it doesn't violate the encapsulation idea. The encapsulation is still here. Nobody can see our 3 attributes. Nobody knows what's inside. They want us to print JSON, we print JSON for them. But they can't get anything from us. They cannot retrieve data from us. They can only ask us to print something, to string, to convert us to JSON string. And then in order to avoid duplication, in order to get rid of duplication, we introduce supplementary, I would call them utility objects, not classes, but objects. So just utilities, some tools which help us to get rid of the code duplication. That's one approach. Another thing, we can use polymorphic media, I would call it that way. So we provide, when we build the method print2, we can instead of print to JSON, we just introduce the method print2, and then we give here some kind of a, I don't know, some kind of a packet or whatever, some media, which accepts whatever it is. So it just accepts data and data and data, some data blocks from us, and then generates some other data array or whatever. In this case, we can. Yeah, let me see the example here. So the point is that we give the media, we give some sort of the destination, the target, where an object can print the data it has, and then how this packet, this media is implemented, it's up to us. So we can give our object different implementation of this destination media, and the object will just drop the data in there, and then the media will decide what to do with that data. So in this case, we get rid of the problem of the single responsibility. The object will be just responsible for what it's responsible already for doing something, and then there's going to be just one method print2, which will actually drop the data somewhere. So again, nobody will be able to retrieve to fetch the data from us. Nobody will be able to treat us as a data container. They will have to come to us with the media and say, how about you print yourself somewhere else? So it's if we try to in the real world example, it's like if I'm the object and you come to me with a piece of paper, you saying write your name on this piece of paper. You're not getting my name from me. You're just asking me to print my name somewhere. The same should happen with the object in object-oriented programming. You come to an object and you ask an object to print itself. And what kind of destination is that? Yes, the first approach is to introduce many printers, but that will violate the single responsibility principle. To get rid of that, to solve that problem, we make just one method and then multiple implementations of the media. In that case, the problem is solved. The problem with single responsibility and the problem with these monster objects will be solved. So to summarize that, I'm finishing. Let me close the screen sharing. Yeah, so to summarize the situation, I want to say that it is important to, first of all, to protect the data inside objects. Data hiding or encapsulation is the most critical thing in object-oriented programming. We should hide our data no matter what, even if it's difficult, even if we sometimes may have this single responsibility violation, this monster objects, the code duplication. It's all second level problems. All of these problems are minor comparing to the encapsulation problem, because when encapsulation is broken, we're not in object-oriented programming anymore. It's something else. It's procedural. We have just code and data. We have code which controls the data. Then we're just getting back to the C programming, to the previous level of programming. So if we want to be an object-oriented, we need to protect our objects. We need to respect them and protect them, and do not let other objects to get into them, to retrieve something from them, to use them as data containers. Because if it happens, everything is ruined. It's not anymore about how much of single responsibility principle you have there. It's not important anymore because there is no object-oriented programming. So first of all, we protect our objects and make sure they do not expose any data through getters. And then if we want that data to get out, if we want that data to be delivered somewhere, then we ask our object to deliver it somewhere. Print it for us, print it to the media, print it to the string, print it to JSON, whatever. No matter how you do it, there could be many solutions. I'm just trying to find a number of them, because I don't see many libraries and many applications doing it that way, because these getters are everywhere. They're so popular in the industry, like so popular in the software world, that it's difficult to find many libraries and many places and many people suggesting solutions for that. So I'm trying to find a number of them. I'm trying to suggest something which I could find, which I can use, which I use in my code. So I use these things. Yeah, I use this media, which is polymorphic, so different kinds of media. I use this supplementary utility objects, which help me to build the content sometimes, to JSON, XML, whatever. And then I'm trying as much as I can to avoid getters at all. Sometimes you have to use getters because libraries expect you to. For example, if you use with Hibernate, then you will have to use getters. If you use with JAX-B, for example, to convert something into XML, you have to use getters. That's inevitable. But I think we should try to stay away from that as much as possible, and maybe not use that libraries anymore if it's possible. But don't make your objects, open data containers. That's what I feel. Let me open the question answer block, and I will see your questions if you have some. Yeah, give me a second. So yeah, I think it's here. Yeah. Okay, we have questions. Yeah, the first question was, it seems that book will have two responsibilities in this case. That's exactly right. We just mentioned that. Yes, we have two responsibilities. There are too many responsibilities, but that's by design. That's how it should be. Yeah, there's a correction about the result value. That's right. It was wrong. That result should be string. Yeah, the question is again, why can't we have book printer and book as DTO? Like I said, that's the whole point of this webinar. So we shouldn't have book as a DTO. DTO is a data transfer object, because in that case we're back to procedural programming. Because in that case, there's data hiding is gone. We don't hide data anymore. We just transfer data from left to right. So in that case, the book is not an object, it's data structure. And data structures, they are from C programming languages. They're not C programming language. It's not from Java. It's not from OOP. It's something else. So the book printer and the book, there's two things. They may exist, but that's procedural programming. It's something which is completely wrong. Why it's wrong, take a look at the webinar number 4. We discussed this problem with getters, many details. The question is, does this just change the level of abstraction that book exists at? Can book have an internal data container message object that it uses to load itself or format itself, etc.? That's a good question. So what about the internal implementation of the book? Can we have some data containers in the book, inside the book? If it's for transferring data from between methods, for example, in the book, between one method to another method, or for in the method procedure, like for example, can we use like a hash map or array or like sort of a data structure? If it's a pure data structure like the list, for example, or a hash map or an array, then yes. But if you still inside the book want to abuse the idea of objects and still make them containers, I would say no, because it's also no good. Because inside the book you will still think procedural way. It's not going to harm us who is outside the book. It's not going to hurt me because I'm the client of the book, so I don't really care what's inside as long as you don't expose me the data you have. But it's going to hurt your thinking. You will start thinking procedural, and sooner or later you will start exposing this data to me as well. You will start giving me these data containers to me. You will deliver them to me, and then the whole design will just ruin. Will just break. So I would say no. I would say stay away from data structures, data containers as much as possible. And if you really want just data structure, use the hash map. In this case, you will tell everybody explicitly that it's just a pure hash map. It's not an object at all. There are no methods in there. It's just hash map. Java doesn't have like native data structure thing. It's just the hash map is a class. So, but it's good to use it. Because in this case you're telling your customers, your users, me for example, that when you give me back the hash map, I know it's of course it's not an object. It's never meant to be an object. It's just a data structure. In this case, it's fine. But don't make objects look like don't make data structures look like objects. Yeah, there's the question, why do we need so many print methods instead of one common print into common media? That's the question was answered. Exactly, that's how we do it. Too much noise in the background. I'm sorry about that. Yeah, I'm trying. Yeah, next time it's not going to happen. Yeah, there's comments saying that I like the idea, focus on encapsulation first and then solve the other problems. That's exactly my point, that you will have problems. You start with encapsulation, you start to encapsulate, you protect your objects, and then you will have a lot of problems, of course. But you solve that problems not at the cost of encapsulation. You don't pay to solve that problem by encapsulation. It's wrong. You just, if you need to sacrifice one of them, encapsulation, a single responsibility, we say, okay, we drop the single responsibility. We build an object bigger, we make it bigger, we introduce more methods to it. We make it responsible for many things. Yes, it may happen. We'll solve it later maybe, but you don't sacrifice the encapsulation idea. One more question. Yeah, there's some best wishes from somewhere, that's good. Note, your approach takes into account object usage, what are known during class development. It's quite unflexible. So yeah, there's like you're saying that I assume that I know how my object will be used, and that's kind of good comment. Again, it's a good comment that you're saying. It makes sense. So you're saying that if I create an object and I don't do any getters from there, so nobody can get any data from me, and then I introduce just one printer which prints to only XML, and then I deliver the library to you, and I'm gone, for example, I stop developing this project, then you're kind of stuck, because you cannot do anything with this object, because it only can deliver the XML to you. But you need JSON, or you need something else. You need it to, I don't know, you just need to get a title from the book. You don't need the entire XML. You just need a piece of data. You just need one title. Then you're stuck. That makes sense. Again, yes, I admit that it may happen. So, but still, it's not an excuse. It's not an excuse to violate the encapsulation and open an object and say, yeah, you know, we're not going to happen. We don't know what's going to happen in the future. So it's not an object anymore. It's just open container. Do whatever you want. This is worse. This scenario is worse than the previous one, where you're stuck and you can only get the XML. Because if you only can get an XML, you still can get XML, and then from the XML you can extract the title, for example, or you can convert the XML to JSON. So you still have the possibility to do all that. But if I'm giving you just a container, then we completely lose control of the object at all, because now you will have procedures sitting around that object, and object is not in charge anymore. It's not object-oriented programming. So that's what I'm thinking. Another question: is it correct that in case of a perfect encapsulation, we don't care much about duplication because it can hurt us? For example, changing implementation of one of duplicating methods can affect another. Exactly. We have two objects, they duplicate each other, but it's not a big problem for us because it's all inside them. This duplication of code happens inside that object. And if something happens with one of them, we don't care about the other because it still works. Because they perfectly encapsulate everything. So of course it's a problem in terms of, you know, if we want to use the JSON library in a better way, then we will have to go through all the places in the code and find how this JSON is being, you know, constructed, and we need to fix it here and there. Of course it's not good. Code duplication is a terrible thing. It's a big problem. We want to avoid that, but not at the cost of encapsulation. I'm saying that again and again. But you're right, absolutely. We will have problem. The code duplication problem will not hurt us that much because it's inside our it's hidden. Another question: how can we get rid of the, for example, JAX-B framework and this approach? How can we get book? Can we get book from XML representation automatically? How can we get book from XML? Yeah, now it's a separate question. So now it's a question about more or less like setters. So you're talking about what if we have an XML? So we have like some text presentation of data. So we have a text stream of data, for example, in XML format. And the question is, how do we build a book from there? It's a separate discussion. It's not about printers. It's how we deserialize, sort of. So when we serialize an object, then we use printers. When we deserialize, we're used to use getters. But in that case, we'll discuss it probably on one of the next webinars. So, but that's a separate problem, and it also can be solved through constructors, obviously. So we need to have, like, I can give an answer right now. So we need to have a constructor which will accept the XML, and it will do the transformation from XML into internal data structure, into attributes inside the object. Again, we'll have exactly the same problems, like what to do with the duplication of code, what to do with the necessity to parse this XML, who will parse it. So of course the object this constructor will kind of contain, probably a lot of code, and the object will be quite huge because we'll be responsible for parsing XML. Like the book will parse XML, the user will parse XML, and maybe 50 other objects will also parse XML. That's probably not right, but it's a smaller problem comparing to the one where we have a data container and then the parsing happens somewhere else, and then we just inject data into the container. That's what I think. What if I build some kind of a search engine which takes a huge criteria? The criteria comes from a client. The only way I see to transfer the criteria to the search engine is to use some kind of a DTO. Yeah, that's what, not just you. There are many people think like that. It's the first idea that, yeah, the data coming in, the data comes from some search criteria. The user typed in something, or there's a huge number of parameters, and then we need to transfer that criteria to the search engine. Like I said, if you really need to transfer just pure data, then use a hash map. Don't call it an object. Don't call it DTO. Use a hash map. The hash map is a perfect solution for transferring data. But if you want to do a bit more object-oriented, like make it less data-focused but more object-focused, then in this case you can create quite complicated object, which is I would say, for example, which we would call like criteria, for example, and then this criteria knows how to. Well, maybe I can't just think right now about the right design. Maybe if you can post that question on the blog, on the article about printers, we can discuss that. Like I would probably be able to suggest some design. But right now, the quick answer is that if you really want to transfer data, then use hash maps or arrays or something like that, byte arrays. But if it's an object, you should not make it DTO. But let's discuss it in the blog. I need to think more about it. If no data values are returned, how can other objects interact with the book? How can I make a program that orders 5 of each book that costs $9 or less? Yeah, if no data is returned, then that's right. So we just assume that you're just asking, like, I'm used to think that my books are just pieces of data. And now I want to find all these data structures which are cheaper than $9. So how do I do that? But the starting step, the first assumption is wrong. You don't treat your collection of your books as just a collection of data structures, of data containers, and then you are in charge. You go into this set of on this list of containers, and then you go through this list, and then you select the right container. You take it from there. In this case, you are in charge. You control the process, which is wrong. They have to control it. You have to go to the bookshelf and say, give me the book which is cheaper than $9. And the bookshelf or the bookstore will give you the right book. How this search will happen inside, it's up to the store. But you don't go through the list of them and just selecting and getting one by one and going into them inside and checking, okay, what do you guys have inside? What kind of value you have from, what kind of data stays inside? So you shouldn't do the search assuming that there's data in front of you. If we are talking about objects, of course, if we are talking about pure procedural algorithm of searching through the array of bytes, then definitely you deal with data. In this case, you're pure procedural. So this is the code. This is in front of you, just a collection of bytes. You go through this collection of bytes. You select the right one. But if we're talking about a higher level, when we deal with objects, then you don't really search through them that way. I hope I answered the question. What can I say? Next question. What can you say about value objects? They're just wrong idea, this value objects. I think so. Well, if they have getters and setters. Because I don't know exactly what people actually mean every time they say value objects. But as far as I understand, for example, is string a value object? Is integer with the big I a value object? If it is, then it's perfect. I mean, it's all right. But if it's not, if it's just a piece of data with a number of getters and setters, then it's a wrong idea. But I actually don't think that the word value is really a good word in object-oriented programming, because value is kind of smells like data value. I hear value, I kind of feel that people are talking about data. And every time you're talking about data, which stays on the same level as an object, so you shouldn't say, "There's my object, there's my data." They're not really on the same level. The data should be always inside an object. An object is the primary, first-class citizen. Data is something which we're trying to hide. We're trying to not see as much data as possible. Another question. Similarly, how would you go on a date with Mary or Lucy if you will never answer any of her questions or tell her any stories? Yeah, it's a good question. I'm not sure how is this related to objects, but yeah, you can. I'm not saying you can never answer questions or tell any stories. I'm just saying that getting data from an object is not really, no Mary, no Lucy would actually appreciate if you are, instead of asking her for a phone number, you would just take her phone and from the pocket and just get the phone number from there. So you're not supposed to get anything from Mary or Lucy. You're supposed to ask them or her to give you an answer. So you're supposed to communicate with an object, and then the data which will go to you eventually, yes, the data will go to you. It's just, I think it's inevitable. But this data, they will go not through a getter. It's not going to be a direct mapping between your request and their internal structure. You should not assume. This is what's wrong about getters, actually, in general. That's it's when you get something from an object, when you use getter, you kind of assume, you kind of rely on the internal structure of an object. You kind of tell that object that I know what's inside you. I know how you build. I know your structure. So now just give me that. Just now give me that that piece of your structure, and that's it. It's not really respectful to the object. Few more questions. I send money from one account to another. Where the logic should be, if in the sending or the receiving account. It depends on the situation, depends on your on your context. But I would say that on the sending, I think if you send from one account to another, so I would say that you get the account from, and then you say .send to, and then another account. I think so. But that depends on the context. You need to look at the. If you print, the next question, if you print objects to media, aren't you limited by the media methods? How can you fork out to JSON, bytes, HTML, etc.? Yeah, it's a good question. So of course it's a problem. How we can build the media the way that it's generic, the way that it accepts all different possible scenarios of data printing. The question is, do we really need that? Do we really need to have our media so powerful so that, for example, all objects will be able to print there? I don't think so. I would design media for each particular object. So, for example, I have a book, and I would say there's book media. I have a user, I would say there's user media. So the book has its own media next to it. So there's my book, I designed the class book, and I designed the class book media. So now if you want me, I'm the book, if you want me to print something to you, implement that class media and give me that object, and I'll print it to you. And that class book media knows how I can print data to there. But the user media is something else, or magazine or article media is something else. So I'm not really, I don't think it's a good idea to create one generic huge media and then just rely on it and give it to all other objects. Well, maybe in some cases, maybe if the application is really contains similar objects, 15 similar objects, they're all kind of the same, like book, article, shoe. I mean, if they're like items in the catalog, for example, they're all kind of the same. And they all need to be able, for example, to print their price, their size, their amount on the stock, and all that things. Then, of course, then the media will be the same for all of them. But in my code, in my examples, every time it's a different media for each object. Hash map. The next question. Hash map, unfortunately, not quite type safe. Yeah, that's true. Yeah, it's unfortunately because it's the limitation of Java. I'm not saying it's good. I'm not saying it's a perfect solution, this hash map, but it's better than DTO. It's better than data transfer object. By the way, another question. By the way, any maps implementations look as evil in your approach? Yeah, I'm not saying that the hash map is a really good approach. It's the perfect one. I'm just saying that they are pure data. And when I see the hash map, I can understand that people kind of know what they're doing. This is data. They mean data. They don't mean objects. They don't abuse object-oriented paradigm. They just need to transfer a piece of data. And this is the hash map is the only thing they found to transfer a piece of data. You can implement your own hash map, your own map, which will be better, which will be not as generic as in Java, which will have, a more better methods to retrieve and put data in and back and forth. But it's still going to be a data structure. It's going to be kind of a would be great if the language would give us something for data structures in the object-oriented world. But I think if we think strategically, long-term, I think the less of these data structures we have, the better for us. The less data we transfer between objects, the better for us. So objects, I think so, they have to encapsulate as much as possible and expose as little as possible. So as little as possible of this data should go outside. The object they should encapsulate, and then they work with that data inside. And when something is required on the outside, it should be something really primitive, like a few numbers, maybe some text, maybe some exception for sure. But it shouldn't be like massive big amounts of data transferred back and forth. I think I read somewhere, I don't remember where, but people were saying that if you see that that you need to pass so much data into the method, and the method needs to return so much data, there's something wrong with your method. So why is that this method is accepting so much as an input and then returning so much as an output? It looks like it's just a gateway or something. It's not really an object. It's not really a self-sufficient piece of functionality. It looks like it's just a gateway. So you just drop in there, and there's just a procedure. It does something for you and returns something back. But the logic is not really encapsulated. It's kind of exposed. Even though it may be not a getter or setter, but still you kind of expose too much if the huge amount of data comes in and huge amount of data goes out. It shouldn't be like that. The method should be small. It should be ideally maybe not even no parameters, like maybe one parameter, maybe two. But if there are like 5 parameters and each of these parameters like a input stream or at the hash map, then something is wrong. I mean, you're definitely making your data stream is too big. Another question, what about data structures with public fields? Getters is not needed. Yeah, that's probably another extreme. We didn't even mention that. We can't abuse objects and just put their attributes and remove the getters and setters. That's a good question, actually. I think that maybe that approach is better than getters and setters. You may look surprised, but I think it's better. It's not good, of course. Yeah, it's still like, it's still a data structure. But I think that this is actually better than using getters. Because in this case, we're obviously saying that, look, it's not really an object. We're not even trying to put any methods there. There's not even any constructors there. It's just pure data structure. It's just pure DTO, whatever. It's just, just the next step after hash map, and maybe the next step, it might be the first step before, the step before hash map. But that's a pure data structure. So maybe you're right. It's a good question. Maybe that approach even is a better solution than these DTOs, which pretend to be objects, which pretend to have constructors, which pretend to have some name and everything. But in reality, it just fools us and gives us the wrong impression of what's going on, the wrong information of how our code should work. So it's a good question. Thanks for that. We have let's make 2 more questions and that's it. Book, that's a comment, probably not a question. Book, the printer, print to page is actually the book telling a story to a page. Exactly. The book is telling a story to the page. When the book wants itself to be printed, it just starts talking to the page and tells the story, explains what's going on, explains who I am. This is my title, this is my ISBN, this is my author. It's exactly the telling the story. Yeah, and then it's up to the page how the story will be understood. Maybe the page will just ignore the story. Maybe it's going to be that kind of page which ignores everything, which doesn't listen to anything. Or maybe it's going to be the page which drops the data to the console. It depends on the implementation. Do you have some real projects at GitHub with implementation of this approach? Yes, I have one project which exactly does what I'm explaining here. You can find it on my account on GitHub. The name of the project is DD, just 2 letters, DD, David. It exactly implements that way. So we have the persistence layer over there. We have data in DynamoDB. This data comes from the database. And then the question is how this data is supposed to be rendered on the screen. So we need to convert that data to HTML. And that's exactly, these data, they have exactly printers. So they don't have any getters. They print themselves, these objects, they print themselves to XML. Look at the project. It's quite small. It's not big. I just created it maybe 1 month ago. And it does exactly what I'm explaining here. One more question, sorry for off topic. What about objects with collections inside? For example, books. In which webinar I can get information about this? There's no difference actually between collections like books and a single book. I don't see any big difference. The only thing is that, again, if you look at that project, which is called DD on my GitHub, then you will see collections there. So we have collections. We have, for example, we have there's 2 things there: pitch and pitches. So pitches, that's a collection of pitches. It's a collection of things in a database. And then there's a single pitch. But the collection never allows anybody to iterate through itself. So there is no method to iterate through collection, even though it's a collection. So it's like there are many pitches inside, but you can go through them. You cannot just loop through them. The only thing you can do is you can ask the collection to render the XML of the entire collection. So this idea of looping through collections is procedural. It shouldn't happen. You should not go through collection looping through it. You should let the collection do some, for example, looping for you, do some iteration for you, but you shouldn't do it outside of the collection. That's, I think, what this is like the heavy inheritance we're bringing to object-oriented programming from procedural programming. We always think this is how I've been taught in school. We start from this variable a equals to 1, and then for I equals to 1 to, I don't know, this is like basic example from a basic language. You go through this loop by index, loop by precondition, loop with the fork, with the post condition. There's like basic programming paradigms, and they shouldn't actually exist in object-oriented programming, because the computer needs them, of course. This is how the processor thinks. This is how the computer thinks. But this is not how we should think if we look at our object-oriented code. I think so. But that's the discussion for the next time. Thank you. This is 1 hour over. Thanks for coming. And yeah, probably we'll have more questions, but you can ask them on the blog under the article about printers, or you can join our chat on Gitter. We have this chat about elegant objects. You can go to my blog, and on the top level of icons, you can find the icon for Gitter. Join the chat. We're discussing it there all the time. Thanks you, and see you in a month. That's the first Wednesday of every month. First Wednesday, 11 a.m. in the morning Pacific time. Thanks for joining. See you later. Bye-bye.